Hello and welcome back to the channel. In today's video I'm going to be running through the Key Stage 2 2022 most recent maths arithmetic paper. This is going to be a walkthrough of how to answer each of the questions. So let's begin. The first question was an unusual question because it was quite a tricky one. But if we look at the numbers, we can work out how to make this easier for ourselves. So take, for example, 501 here, add 649. If I notice that if I add 1 here to 649, it makes 650, what I need to be able to do is 500, add 650, and then it's going to be 0 add 0 is 0, 0 add 5 is 5, 5 add 6 is 11, which gives me 1,150. But I'm not quite finished there because now I need to add the 6,155 remaining as part of this question. So again, I'm going to use column method. So 6,155, add 1,150. 5 add 0 is 5. 5 add 5 is 10. So 0 down, carry the 1. 1 and 1 is 2 and 1 is 3, 6 and 1 is 7, giving me a final answer of 7,305. Question number 2, 0 multiplied by 989. Now, what I say to all the children is if you ever get a question that is anything times 0, it means you have 0 groups of 989. So if we have 0 groups, we have nothing at all. So the answer is an obvious 0. The next question is a missing number question. So we've got 10 add something is 302. So what am I going to add to 10 to make 302? Well, for this question, we can actually do the inverse. So we can do 302, take away 10. 2 take away 0 is 2. 0 take away 1 we can't do, so we will borrow. That becomes 2. That then becomes a 10. 10 subtract 1 is 9. And we bring the 2 down, 292. So if I add 10 and 292 together, I should get a final answer of 302. So also, just to be aware of, if the equal sign here is not at the end of the sum, if it feels like it's in the middle, and what we say to the children is it's like a balancing scale. Whatever is on this side has to be equal to whatever is on this side. So if I add 10 and this number together, that will equal this number here. Okay. Question number 4. 2,400 divided by 2. Now, the children could do a formal method for this question. However, if they can use their known number facts, so to know that 24 divided by 2 equals 12, then 2,400 divided by 2 would also equal 12, but with the 2 zeros additional on the end. And if I divide 2,400 by 2, I will get the answer 1,200. Question number 5. Something add 70 equals 485. So, with this question again, the equal sign appears to be in the middle of the equation. So we have an answer here, and then we've got a missing number here. So something, and when added to 70, makes 485. So once again, I'm going to take 485. I'm going to subtract 70 from that number. So essentially, I'm doing the inverse. 5 take away 0 is 5. 8 take away 7 is 1. And we bring the 4 down, 415. Don't forget, children must write the answers in the box in order to get the answer correct and get the mark at the end. So if we look here, 415 plus 70 would equal 485. And if I do this mentally in my head, 10 and 70 is 80, plus the 5, 485. Question number 6 is our first decimal question, and it is 6.48 plus 8.6. What I say to the children, it's really important when doing a question like this that we make sure we put the numbers in the right places. Because an easy mistake that lots of children make is they forget to put the zeros for where their placeholders should be. So I say, let's start with the whole numbers first. So we have 6 and we have 8. Then we're going to put the decimal points on, like buttons on a shirt, one underneath the other. Now we can put the tenths, so it's 6.4 and 8.6. The top number has a number in the hundredths, so we will put that in, but the number underneath does not. So we need to remember to put a 0 as a placeholder. And now, just checking the operation is addition. 8 add 0 is 8. 4 add 6 is 10. Okay, so it's a 0 and carry the 1. 6 and 8 is 14. Plus 1 is 15. Make sure then the decimal points line up. So the answer is 15.08. Let's move on. Okay. Question number 7 is another question which involves the children knowing their known facts. In this case, the 8 times table. So we have something equals 240 divided by 8. And just as before, as I was talking about, we have the equal sign in the middle of the equation here. So whatever this is has to equal this side. So this side has to be the same as this side, like a balancing scale, okay? Now, 240 divided by 8. The children might want to use a formal written method to do this, but as they're short on time in this test, they should try to use their known facts. For example, 24 divided by 8 equals 3, because 3 times 8 is 24. So 240 divided by 8 is going to be 3, but with the additional 0, 30. So the 8 times 30 is 240. So something equals 240 divided by 8. The answer should be 30. 30 is equal to 240 divided by 8. Okay, next question. 840 divided by 5. Now for this question, I would recommend doing a formal written method. So we're going to use the bus stop written method. So the first step is to draw the bus stop. And the big number, 840, is going to go under the bus stop, sheltering from the rain. And the smaller number is going to go on the outside. So we start by going to know how many 5s go into 8. 5s into 8 goes once with 3 remainder. 5s into 34. Let's count in 5s to work out how many. 5, 10, 15, 20, 25, 30, 35. 35 is too big, so we'll go back to 30, which was 6 times, with 4 remainder, leaving us with how many 5s in 40, which is an easy division to do. 5 times 8 is 40, so 40 divided by 5 is 8, giving us a final answer of 168. The next question is our first, our first subtraction question involving a formal written method. And like with the addition, we're going to use column method. So the large numbers going on top, 7,306, with the smaller number underneath, 1,847. Just double check that I have the operation correct, subtraction. So 6 take away 8, I can't do. Sorry, 6 take away 7, I can't do. So I'm going to borrow. Can't borrow from the 0, it's too small. Can't borrow from the 3, it's too small. So I'm borrowing from the 7. 7 becomes 6. 3 becomes 13, which then I borrow from, which becomes 12. That becomes 10, which I borrow again from, which becomes 9. Finally, we have 6. 16 minus 7 gives us 9. 9 take away 4 gives us 5. 12 take away 8 gives us 4. And 6 subtract 1 gives us 5. Now when writing the answer, try to put the comma in, but it's not necessary to get the answer correct. So it's 5,459 as a final answer. Okay, next question. 1,000, 0 and 10 multiplied by 10. So 1,010 multiplied by 10. Now, this question is our first place value question. Some children may be able to do this in their head by thinking that they can add an additional 0. However, what I would encourage all the children to do in order to get this correct is to quickly draw a place value chart, which means I draw the columns on my exam paper. And as a teacher, you should be encouraging your children to draw these quickly and efficiently so they can use them in the test. So I'm going to use here, I'm going to put hundreds of thousands, tens of thousands, hundreds, tens, ones. Because we're multiplying, it's not necessary for us to draw the decimal. But if we wanted to, the decimal point would go here, and this would be tenths. Okay, now we put in the number. 1,000, 0, and 10. When we're multiplying by 10, I encourage the children to understand that we're going to do one jump, and because we're multiplying, it's one jump to the left. So all the numbers are going to jump one to the left. The 1 goes in the tens of thousands, the 0 to the thousands, the 1 to the hundreds, and the final 0 to the tens, giving us a final answer of 10,100. Now we go on to question 11. So this question is 560 divided by 7. Now this question, again, is about the children knowing their known facts. So you'll need to know your 7 times table, but essentially if you know that 56 divided by 7 equals 8, then I should know that 560 divided by 7 is going to be 80, because 560 is 10 times bigger than 56, so the answer therefore has to be also 10 times bigger. 6 multiplied by 10 multiplied by 11. For this question, we're going to start off by doing 6 multiplied by 10, which gives us 60. Then we're going to do 60 multiplied by 11, and you can do that in a number of different ways, but you can just use your formal written method. So 60 multiplied by 11, 0 times 1 is 0, 0 times 6 times 1 is 6. Then we put our 0 as our placeholder because we're now multiplying by the tens. 0 times 1 is 0, and 6 times 1 is 6. The final part is to add those two answers together, giving us a final answer of 660. There are a number of ways of doing this type of question. However, as long as they remember to multiply all 3 numbers, they'll get it correct. Okay, let's move on. Question number 13. So, a tricky question, because if you look at the numbers, it almost looks like 180 could be divided by 9, and we're going to be doing that, okay, which would leave us with an answer of 2 or 20, all right, which is why I've got this crossed out here, because that's not what it's asking. 1,080 divided by 9, if I look at that number 1,080, what do I notice about it? That it's 10 times bigger than 108. So if I do 108 divided by 9, once again, I've got to use my known facts. 9 times 12 is 108. So 108 divided by 9 is 12. Now I take the number that's in the paper, 1,080 divided by 9. The number is 10 times bigger than 108, so the answer therefore has to be 10 times bigger. 1,080 divided by 9 therefore is 120 with the additional 0. 120 is our final answer. Okay, question number 14. 500,000 take away 5,000. Now, this is a very straightforward place value question, and essentially, what it's asking is, what is 5,000 less than 500,000? Now, children could count back in thousands. However, a lot of children might want to use the formal written method to do this. However, because they've only got a short amount of time in this test, it's probably best if they just try to count back in their heads. So 499,000, 498,000, 497,000, 496, 495,000, giving us a final answer of 495,000. Okay, question number 15. Something equals 596 multiplied by 7. Now, once again, they've tried to confuse the child here by putting the equal sign in the middle of the equation. However, if you speak to your children and you say, whatever happens, if the equal sign is in the middle, it just means that this side must equal this side. It's like a balancing scale. So if I do 596 multiplied by 7, then it should be the answer that's given here. So we do 6 times 7, which is 42. Okay, 2 down, carry the 4. 9 times 7, which is 63. Add 4, is 67. So 7 down, carry the 6. And 5 times 7, which is 35, plus 6 is 41. Giving us a final answer of 4,172. Okay, let's move on. Question number 16. We have another question involving multiplying, dividing by 10, 100, 1,000. So once again, just like the other question, I know that some children may be able to move these numbers or do this in their heads, but it's an easy question to make a common mistake, okay? So let's make sure, I would always encourage the children in my class to draw that place value grid again. So I'm going to draw out the columns. And you should be teaching your children to try and do this quickly and efficiently, so it doesn't take too much time out from the test. So just literally draw the columns like this, and then we put in the hundreds, tens, ones, decimal point, tenths, hundredths, thousandths. Okay, and once again, because it's a test, you don't have to get them to write this accurately. Okay, it's just for the purpose of solving the question. Then we put in the number that we're doing dividing by 10, so it's going to be 2.12. And now we're dividing by 10, so I encourage the children when dividing by 10, the numbers are going to jump. And in which direction? Well, because we're dividing, they're going to jump backwards because the answer is going to get 10 times smaller. We're dividing that part into 10 smaller parts. So this number jumps to here, this number jumps to here, and this number jumps to here, giving us a final answer of 0.212. 0.212. Okay, so the next question is our first 2-mark question on this paper, because it's a long division question, okay, or short division question. Now, it's really important that, like it states here, the children show their working, show their method within this question, because even if they get the final answer incorrect through a calculation error, they can still receive a mark for their working out. So again, I'm going to draw, you could get them to draw the bus stop method, or it's already been put here for them. So there are a number of ways you can do this. You could try short division, but I'm going to do long division. So what we encourage the children to do is to do jottings down the side. So the 21 times table, so 21. And then 21 times 2 is 42. 21 times 3, 2, 4, 6, and 3, so 63. 21 times 4, 2, 4, 6, 8, 1, 2, 3, 4, 84. 21 times 5 would be 20 times 5, which is 100, and then 105. 21 times 6 will be 100. 126, I think. Okay, let me just check that. 21 times 6, and they can do this also in the test. 1 times 6 is 6, 2 6s are 12, yeah, 126. So now we know what our jottings are, we can go ahead and do this. Okay, so that is 1 times, 2 times, 3 times, 4 times, 5 times, 6 times. We may need to go another time, but we'll see. So the first thing is 21 into 67. Well, 21 into 6 we can't do, so we're going to do 21 into 67. Now 21 into 42, it goes in 3 times. Look, so we'll put the 63 underneath. Okay, and then what we do is we take away 63 from 67 to see what we've got left over. So 7 take away 3 is 4, 6 take away 6 is 0. Bring the 2 down, then we've got 42, which works out nicely. Oh, don't forget to put how many times it went in. So it went 0 times. 67, it went in 3 times. And how many times does it go into 42? It goes in, look at my jottings, it goes in twice. So 42 here. And is there going to be any remaining left over? 2 take away 2 is 0. 4 take away 4 is 0. So it went in 2 more times, giving us a final answer of 32 with 0 remainders. Now, it's only possible to do that question if we write down our jottings, okay? There are other ways of doing it, but I find the jottings really help the children to work it out quickly and efficiently. Okay, let's go on to our next question. Question number 18. For this question, it's our first real fractions question, and it is adding fractions with different denominators. Now, for this question, it's important that the children don't try and add the denominators together or add the numerators together at this stage. What we want to do is to try and get the denominators to be the same. So we need to find the lowest common multiple, the lowest common denominator of both. So what I say to the children is, we're going to just create a space here, okay, where we're going to add our fraction together. But let's write down the 9 times table. 9, 18, 3 9s are 27, 36. And quickly write down the 3 times table. 3, 6, 9, 12. Now, which number appears in both of these multiple times tables and we can use as the lowest common denominator? It's 9 and 9. Okay, so the denominators are going to be 9. Now, for this one, 4 9ths, I don't need to do anything because it's already in ninths. So it's just this one that I need to change. So what you say to the children is, how do you get from 3 to 9? Well, you multiply it by 3. Okay, to get it from 3 to 9. So whatever we've done to the bottom number, we must do to the top number. So then I do 2 multiplied by 3, which makes 6. Okay, and then give me a final answer of 10 ninths, which is an improper fraction. But then I can convert that into a mixed number fraction by thinking how many ninths have gone in and how many is left over. Well, you can do a very simple division here. So this line here, which is called a divisor, basically means divide. So 10 divided by 9. Sorry, the other way around. Yep, no, that was correct. 10 divided by 9. How many 9s go into 10? There's 1 with 1 remainder. So that would mean that there's 1 whole 1 and 1 9th left over, giving us a final answer of 1 and 1 9th. Now, interestingly, in the mark scheme, it can accept 10 ninths as a correct answer, but it can also accept 1 and 1 9th. So you can get a correct answer for the improper fraction, and you can also get a mark for the mixed number fraction. Okay, question 19. I believe this is the first of our long multiplication questions. Now, once again, it's a 2-mark question, which means that it's really important that the children show they're working, even if they can do it in their head, because if they get the wrong answer here, they can still get a mark for showing they're working. So it's drawn out for us already, which saves us some time. So let's begin. 7 times 3 is 21. 1 down, carry the 2. 0 times 3 is 0, but with the 2, we've got 2. And 6 times 3 is 18. Right, now I'm going to multiply the 10, so I need to remember to put a placeholder in the 1, so I'm going to put a 0 there. 7 times 8 is 56, So we're going to put the 6 down and carry the 5. 0 times 8 is 0, but with that 5 it's 5. And 6 8s are 48. Now I've got both numbers. The next thing I need to do is to add those two parts together. So we're going to do 1 times 0 is 0. Sorry, 1 add 0 is 0. 2 add 6 is 8. 8 add 5 is 13, sorry. 3 down, carry the 1. 1 add 8 is 9, and 1 is 10. So 0 down, carry the 1. And 4 and 1 is 5. Giving us a final answer of 50,381. Sorry, I did 1 add 0 is 0, but it should be a 1 there. So 50,381. Now, if I had written 50,380, I would have not got the final answer correct. However, because I showed my working, I would have got at least 1 mark on that question. So I showed you that mistake on purpose so that you can see that how important it is for the children to show their working. Even if they make a small calculation error here and they write the wrong answer, they could still get a mark for their working. But the actual answer is 50,381. Okay, let's move on. Question 20. Question number 20. Once again, we've got a number here and we're multiplying by 1,000. So as with before, I'm encouraging the children to draw their place value chart out. And we're working with thousands here, and we're going to be multiplying, so we're going to be going up. So I need to make sure I've got enough columns on this side. So let's try hundreds of thousands, tens of thousands, thousands, hundreds, tens, ones. Won't probably need the decimals, but I'll put decimal point there just to show you. So now we put the number into the place value chart. So we've got 13. Oh, we will need the decimal, sorry, 0.05. And now we're going to multiply that number by 1,000. Now, when multiplying, we should encourage the children to understand that you're going to be making jumps forwards or to the left of the place value chart. And when we're multiplying by 1,000, they're going to be making 3 jumps in total. Okay? So, now we can physically move the numbers. 1, 2, 3. So the 1 can go here. 1, 2, 3. 3 is going to be here. We also move the 0. 1, 2, 3 jumps. And the 5. 1, 2, 3. And then we've got a 0 to put in the ones column, giving us a final answer of 13,050. 13,050. Next question. Here we've got an addition of fractions, but we're now adding a mixed number fraction to a normal fraction. So what we need to do is to convert this fraction here, okay, into thirds, all right? So that's an improper fraction. So this one will remain as 2/3. How many thirds are in 2 whole ones? There are 3, isn't it? 3/3. So this 2 will become 3/3 to make 1 and 3/3 to make 2. Okay, because that's 1 whole one and that's 1 whole one, making 2 whole ones. So if we add all those thirds together, it's 3 and 3 is 6 and 1 is 7. So that should be 7/3 now as an improper fraction. And if we add those together, we've got 2 add 7 equals 9. So that's 9/3 altogether. Now, I'm sure with this question, we want to be accepting equivalent fractions. So 9/3. Let's see how many wholes is that then? So we're going to do 9 divided by 3, because this line here is the divisor. That's what it means. It means this number divided by this number. So how many 3's in 9? There are 3 with nothing left over, which means that what 9/3 is equal to is 3 wholes. So 3 wholes is our answer. Question 22. 7/10 of 30. So for this question, this is our first fractions of amounts question, and the rule is with these questions is to divide by the bottom and multiply by the top. So if I do 30 divided by 10, I get an answer of 3. And if I multiply 3 by 7, so we're dividing by the bottom first, 30 divided by 10 is 3. 7 multiplied by 3 is 21, giving us a final answer of 21. With those questions, the rule is just simply to divide by the bottom and multiply by the top. Earlier in their education, they would have done some drawings. In year 2, they would have drawn groups, because essentially what you're saying is what are 10 groups of 30, so 30 divided into 10 groups, and then you're basically counting 7 of those groups. But here, with the children in year 6, they already understand that, so we can just go straight to divide by the bottom, multiply by the top. Okay, let's move on. Question 23. This is an interesting question because we are going to be subtracting decimals from a whole number. So just like with our other decimal question, it's important that they put the numbers in the right places and they put down their placeholders. So I'm going to start off with my whole numbers, 8 and then 5 underneath. Then I'm placing my decimal points on here like buttons on a shirt. So 8, 1 decimal and the other decimal underneath. Now I can add in my decimal places, so 5.1, 2, 3, and the most important part, to put those placeholders in, so 8.000. Given that it's just make sure we know that it's subtraction, just check that. 0 take away 3, can't do, so now I borrow from the 8, becomes 7. This becomes 10, but it's 9 again. This becomes 10, but it's 9, and this becomes 10. 10 take away 3 is 7. 9 take away 2 is 7. 9 take away 1 is 8. And then 7 take away 5 is 2. Don't forget to line up your decimal point and put it back into your question, giving you a final answer of 2.877. Okay, for question 24, we've got 1/8 divided by 2. Now, with these questions, what I say to the children is, okay, we're basically splitting a fraction of an eighth up into 2 parts. If you can't divide the numerator by the 2, so we can't do 1 divided by 2, then what I say to them is to multiply the denominators and keep the numerator the same. All right, so the numerator is going to remain the same, and I'm going to do 8 times 2, which is 16, giving us a final answer of 1/16. So a little trick for questions like this, if you can't divide the numerator by this whole number, then just multiply the denominator by the whole number. And as we know, if we were to split 1/8 into 2 parts, we'd be given 1/16. Question. We have another question where we're adding fractions with different denominators. So just like with the other question I did, we need to find the lowest common multiple. So I'm going to start off by just creating a space for my question, and then I'm going to write down the 2 times table, 2, 4, 6, 8, 10, 12, 14, and then I'm going to write down the 3 times table, 3, 6, 9, 12, and already we can see we've got our lowest common denominator, our lowest common multiple, which is 12, which is going to be our denominators. Then we do, how do we get from 2 to 12? We multiply it by 6. So then we multiply the numerator by 6. How do we get from 3 to 12? We multiply that by 4. 3 fours are 12. So we multiply the numerator by 4. So that's 4. Now we can add these together. 6 add 4 is 10, giving us a final answer of 10/12. 10/12, which would be accepted, okay, but can you also simplify that? So if I divide 10 by 2, I get 5, and if I divide 12 by 2, I get 6. So you could have had 10/12, but if you simplify that fraction, and you should be encouraging your children to learn to do that, gives a final answer of 5/6. Great, let's move on to the next one. Question 26. Once again, we've got a whole number, take away a decimal number. So Just like with the other decimal questions, let's encourage the children to lay it out really correctly first. So we're going to write down our whole numbers first. We've got 26. Then we have no tens, but we have got 2. Now the decimal points, line them up like buttons on a shirt, one underneath the other. And then we're going to put 26. There's no decimal places, so we'll put the others in, 0, 1, 2. But the most important part, let's put our placeholders in, 0, 0, 0. Now we can solve this, check the operation, subtract. Can't do that, can't do that, can't do that. I'm going to borrow from here. That becomes 5. That becomes 10, which becomes 9. That becomes 10, which becomes 9. And that becomes 10. 10 take away 2 is 8. 9 take away 1 is 8. 9 take away 0 is 9. 5 take away 2 is 7. And then the 2 is left on its own. Line up your decimal points, so it should be here, giving us a final answer of 27. Oh, I've made a mistake here. If you noticed, I did 5 add 2, which equals 7. Okay, so I need to just cross that out, look back at it. 5 take away 2 is 3, which just shows you how easy it is to make a mistake if you're going too quickly on questions like this. So the final answer would be 23.988. Question number 27. So this question is our first percentage of amounts question. 15% of 3,200. Now there are lots of ways of doing this. You could find 10%, okay, by dividing this by 10, and then find 5% by halving 10%. Or a quick way that I show the children is that if you multiply those numbers together, but then divide the final answer by 100, that's another way you can do it. So if I just do it this way, because a lot of the children like to do it this way, 3,200 multiplied by 15. 0 times 5 is 0. 0 times 5 is 0. 2 times 5 is 10. 0 down, carry the 1. 3 times 5 is 15, and 1 is 16. And then I'm going to do 0 placeholder here. 0 times 1 is 0. 0 times 1 is 0. 2 times 1. 1 times 2 is 2. And 1 times 3 is 3. Add those parts together. 0, add 0, 0, 2 and 6 is 8. But then at this point, I need to divide the answer, the final answer, by 100. So an easy way to do this that I tell the children is to just cross out the 2 zeros, in this case, giving us a final answer of 480. Okay, let's move on. Question number 28. 2% of 3,000. So another percentage of amount fraction. Okay, so again, like I did with the other one, what you can do is you can multiply these, or an even quicker way, if you're finding 1%, you can divide it by 100 to find 1%. So I'm going to take off the 2 zeros, giving me 30. So 1% will be equal to 30, but I'm actually looking for 2%. So I'm going to times that by 2, which gives me 60, giving me a final answer of 60. Okay, so question 29, another question which is worth 2 marks because this is a long division question, probably one of the hardest questions on the paper. And again, once again, it's really important that the children write down their jottings down the side here. So essentially what I've done already is written down the 73 times table up to 73 times 5. I may need more than that, but we will see when we work it out. To do this, you have to do jottings on the side, so 73 times 2, and then you have to work it out and then put your answers down here. So it does take a little bit of time, but it's a 2-mark question, so it's worth spending the time doing it. So the first thing we're going to do is, how many times does 73 go into 30? Well, it doesn't. So how many times does 73 go into 306? So let's have a look down here. It's going to go in 4 times. So 292, we can write that underneath. Okay, and then we subtract. So we do 6 take away 2, which is 4. 0 take away 9 you can't do, so we're going to borrow. That becomes 2. And that becomes 10. 10 take away 9 is 1. 2 take away 2 is 0. And then bring the 6 down. Now if we look here, how many times did it go into 306? And go back here, it went in 4 times. So it didn't go in there, it didn't go in there, but it went in there 4 times. Now 146, look, it appears perfectly there as 2 times 73. So I'm going to put, it goes in twice, and I'm going to write that underneath. And just subtract to make sure, double check there's nothing left over. 0, 0, and 0. No remainders, giving us a final answer of 42. Now, interestingly, it tends to be that your long division questions tend to work out with no remainders on the test. That's how it's been for the last couple of years. So I say to the children, there's a likelihood it won't have a remainder, but it's not a certainty. Okay, let's move on. Question number 30. Again, we have a percentage of amount question now. And it's saying how many percentage, 80% of 115. Now, once again, the children like to solve this by doing 115 times 80. Okay, and then dividing that answer by 100. But let's try a different way for this. Let's see if we can do 10% of 115. So 10% of 115 would equal, well, we divide 115 by 10, 11.5. And then we would have to multiply that 10 by 8. Okay, which would be one way of doing it. But let's see if we get the same answer doing it this way. So 115 times 80. 5 times 0 is 0. 1 times 0 is 0. And 1 times 0 is 0. Placeholder, 5 times 8 is 40. So I'll put the 0 down and carry the 4. 1 times 8 is 8. Add 4 is 12, so 2 down, carry the 1. 1 8 is 8 and 1 is 9. That gives us 92,000. And then we divide the answer by 100. So like I said before, we just cross out the 2 zeros, giving us a final answer of 92. Okay, now, if we did it that way, would it have been the same? 5 times 8 is 40, so 0 down, carry the 4. 1 8 is 8 and 4 is 12, so 2 down, carry the 1. And 1 8 is 8 and 1 is 9. Okay, put your decimal point in. You can see it gives us the same answer. Okay, so question number 31. We've got a subtraction here with fractions with different denominators. So we need to get the lowest common denominator. And like I was doing before, I'm going to write down the 7 times table and the 9s. I'm going to find that lowest common denominator. 7, 14, 21, 28, 35, 42, 6 sevens are 42, 7 sevens are 49, 8 sevens are 56, and 9 sevens are 63. Now, interestingly, if I know it's 7 and 9, I'm going to guess that the lowest common denominator is going to be 63, a combination of multiplying those together. 45, 54, 9 times 6 is 54, 9 times 7 is 63. And there you have it, 63. So a quicker way of doing it could have been just to multiply those together, but you have to be sure. So the other thing is that this diagram will help you in a minute. So 63 is going to be our denominator. How do we get from 7 to 63? We times it by 9, so 2 9s are 18. How do we get from 9 to 63? We multiplied by 7, so 1 times 7 is 7. Add those, subtract now, because it's just double check that. 18 take away 7 is 11, so it's 11 over 63. And that's our final answer. We can't simplify that fraction, really, because we can't divide 11 by 2. So 11 63rds is our final answer. Okay, question number 32, coming towards the end of the paper now. So we've got a subtraction of mixed number fractions. So here we need to make this into an improper fraction. So I'm going to leave this as 2/3 for now. And this one is going to be 1/2, but we've got 2 more whole ones, which would be 2 halves and 2 halves, making that 4 halves plus that 1/2 would be 5 halves. Okay, so we've got 5 halves, take away 2/3. But then again, I need to find the lowest common denominator. So I'm going to put half 2 here and 3 here. 2, 4, 6, 8, 10, 3, 6, 9, 12. The lowest common denominator being 6. So that's going to be our denominator, 6 and 6. How do I get from 5 to 6? Sorry, how do I get from 2 to 6? I times it by 3. Okay, so then I times the numerator by 3. 3 times 5 is 15. How do I get from 3 to 6? I times it by 2. So 2 times 3 is 6. Okay, so then I do 15 sixths, take away 6 sixths, should leave us with 9 sixths. I just realized I'd made a mistake here. Okay, so you can see how easily it is done. So here, I did, how do I get from 3 to 6? I times it by 2, but then I did 2 times 2 is 6, which it isn't. It's actually 4. So if I've changed that now, it's actually 15 sixths take away 4 sixths, which would leave me with 11 sixths. So 11 sixths is the actual answer there. I think it's always important to the children to see that we also make mistakes, and that's how we learn. And that's why it's also important at the end of the test for children to go back and check their answers. It didn't look right to me, so I went back, I had another look at my working out, and I spotted my error here. So that's how it's so important to go back and check your answers. Okay, so the next question, question 33, is a 2-mark question. Well, once again, we have to show our working here to get that extra mark. But it's a long question. It's a long multiplication question because it's going to take some time to do this. So first of all, starting with the ones, 8 times 7 is 56. So 6 down, carry the 5. 7 times 7 is 49. 49 add 5 is 54. Okay. So I'm going to put the 4 down and carry the 5. 0 times 7 is 0, plus that 5 is 5, and 4 times 7 is 28. So that's the first bit done. But now we're going to look at the tens. So we're going to put up 0 as a placeholder, because we're multiplying by tens now. 8 times 6 is 48. 6 eighths are 48. So I'm going to put 8 down, carry my 4. 7 times 6 is 42, plus the 4 is 46, 47, 48. 7 times 6 is 42. Plus the 4 is 46. So I'm going to put the 6 down, carry the 4. 0 times 6 is 0, but with that 4 is 4. And 4 times 6 is 24. Okay, so I'm going to now add those two parts together. 6 add 0 is 6. 4 add 8 is 12, so 2 down, carry the 1. 5 and 6 is 11, and 1 is 12, so 2 down and carry the 1. 8 and 4 is 12, but that 1 makes 13, so 3 down, carry the 1. 2 add 4 is 6, and that 1 is 7. And then 2 add 0 is 2, leaving me with a final answer of 273. 273,226. Now, if they did make a calculation error at any point during this, showing their working means they will get at least 1 mark from this question. So that's why it's so important to show your working here. Okay, moving on to the last page. So question 34, what I've drawn here is what a child might do if they were doing this question wrong. So what they might do is try and do 10 take away 2, which is 8. And then try to find a quarter of 10, which would be 2.5, okay, and then add those together to make 10.5, which wouldn't give them a correct answer. So what you should be doing is you need to convert both this and this into improper fractions so that they both have quarters underneath. So let's have a go at this. We've got 2 wholes. 2 wholes as quarters will be 4 quarters and 4 quarters. Okay, 4 quarters and 4 quarters, which would make that 8 quarters. Okay, so 2 wholes is 8 quarters, plus that 1 quarter will be 9 quarters in total. Okay, you can see how I've managed to get 9 quarters, all right? But what about 10 wholes? Now, that would be 4 quarters times 10, okay, which would give me 40 quarters. So now I've got both fractions as quarters. It's improper, but I can actually do this question now. So 40 quarters subtract 9 quarters would give me 31 quarters. And that would be an acceptable, correct answer for that question. So quite a tricky question, but whenever you've got a question like this, you want to try and make it so that both sides are the same. So in this case, taking those whole numbers and turning them into improper fractions. Okay, question 35. Unusual, there was only one question on this on the paper, but this is our first BIDMAS or BODMAS question. BIDMAS is something you teach the children to get them to understand the order in which a calculation should be done. So B stands for brackets, I is indices to the power of, D is division, M is multiplication, A is addition, and S is subtraction. So what we should be doing here is, what should we be doing first? So B, there's no brackets, there's no indices, but there is division. So I should be doing my division first. 4 divided by 2 is 2. And then I can do my addition. So I do 6, add the 2, which gives me 8. So with that kind of question, the maths itself is not difficult, but understanding the order in which to do it is what they're being tested on. Okay, and the final question on the paper, 36. In previous years, this has been a long multiplication or long division question, but interestingly, this came earlier in the paper. This question is a fractions of amounts question. So as I said before, we're going to divide by the bottom and multiply by the top. Looking at those numbers, 400 is similar to 40. I know that that's in the 5 times table. So 400 divided by 5, 40 divided by 5 would be 8. So this is going to be 80. And then if I multiply that by 4, well, 4 times 8 is equal to 32. Okay, so if I do 4 times 80, that's going to be equal to, add a 0 to that answer, 320. Give me a final answer of 320. Thank you for watching the video, guys. I hope you found some value in it. It's important for the children to understand that whatever happens, okay, they don't need to get every single mark on this correct, but they can get marks for showing they're working. So for those questions where they show they're working, they must, okay? I've shown you a couple of different ways to answer these questions, but I've also shown you a couple of ways that children might make easy mistakes. So what I would encourage the children to do once they finish their paper is always to go back and check through every single question if they can, if they have time. They have to work as quickly as possible because it is only a 30-minute test. Hope you find some value in it. If you haven't subscribed to the channel, please subscribe because I'll be putting some more videos up about the Key Stage 2 2022 SATs, and hit the like button because it really helps the channel out. Thanks for watching, guys, and I'll see you in the next one.